An isolated ground circuit is an electrical circuit in which the neutral wire is isolated from the grounding system by a transformer. This prevents current from flowing through the neutral wire into the ground, thus creating a dedicated path for equipment operation. Isolated ground circuits are highly effective in eliminating ground loops and ensuring the proper operation of sensitive electronic equipment. By isolating the ground path, isolated ground circuits firstly reduce electrical noise. Ground loops can cause interference and noise in sensitive equipment, leading to malfunctions or errors. Isolated ground circuits eliminate these ground loops, resulting in cleaner and more reliable signals. Secondly, they improve system stability. Ground loops can create unpredictable current flows, which can destabilize electronic systems. Isolated ground circuits prevent these current flows, improving system stability and reliability. Thirdly, they enhance equipment lifespan. Electrical noise and fluctuations can damage electronic components over time. Isolated ground circuits protect equipment from these harmful effects, extending their lifespan. Isolated ground circuits are particularly beneficial for the operation of sensitive equipment, such as firstly medical devices. Ensuring reliable and accurate performance of medical equipment is crucial. Isolated ground circuits eliminate ground loops and electrical noise that can interfere with the proper functioning of medical devices. Secondly, laboratory instruments benefit. Laboratory instruments require precise measurements and accuracy. Isolated ground circuits minimize electrical noise and ensure proper grounding, reducing errors and improving the reliability of measurements. Thirdly, computer systems also gain advantages. Computers are vulnerable to electrical noise and fluctuations. Isolated ground circuits provide a stable and isolated ground path, preventing data loss or errors caused by electrical interference. While isolated ground circuits offer significant benefits, there are some practical considerations to keep in mind. Firstly, installation costs can be higher. Installing isolated ground circuits requires specialized equipment and expertise, which can increase installation costs. Secondly, maintenance is crucial. Isolated ground circuits require regular maintenance to ensure proper isolation and prevent ground faults. Thirdly, there are limitations. Isolated ground circuits are not effective in eliminating ground faults or overcurrent conditions. In conclusion, isolated ground circuits are indeed effective in eliminating ground loops and ensuring the proper operation of sensitive electronic equipment. They provide a dedicated and isolated ground path, reducing electrical noise, improving system stability, and extending equipment lifespan. While there are some practical considerations associated with their installation and maintenance, isolated ground circuits offer significant benefits for applications where reliable and accurate electrical performance is critical.